Welcome to another episode of my construction video. Now, in this video, we are going to be talking about preparation of bar bending schedule. So it is based on preparation of bar bending schedule. And in this episode, I'm going to spread the video into three chapters. That's into three parts. And the reason why I will be doing this is to have the video so that I will not have everything in one video, because a long video will discourage someone from watching. So I will split this into three or four different parts. And in this first part, we are going to be talking about the bending schedule, and I will show you an example of a bending schedule I have done. And in the part two, we are going to be talking about bending schedule. We are going to be doing it in AutoCAD. We are going to be doing a bending schedule. I will show you how I arrive at the one I'm going to show you in this video. Then in the third part, I'm going to compare two methods of doing bending schedule. So I'm going to compare the two method of bending schedule, and probably we might have the fourth part, which might be on slab, doing the bending schedule for slab, because I'm going to be using beam majorly for this exercise. So welcome, I hope you learn from this video. Now join me and let's begin. Or preparing a bar bending schedule, just like I said in the introductory part, that in this video we are going to be doing a preparation of a bar bending schedule. So let's go to the content and let's see what we're going to do today. So in this video, what I'll be covering in this video is what a bar bending schedule entails, uses of bar bending schedule, and an example on bar bending schedule. I told you there is an example I've done, so I will show you and just explain how I have arrived at the answer. Then in the part two, we are going to be doing a bar bending schedule. So let's go to the content of the video and so what bar bending schedule entails. So bar bending schedule is just a table, a table that we use inside for reinforcement work, majorly on reinforcement. That is what bar bending schedule is used for. So whenever you hear bar bending schedule in construction, it's just a table that shows the arrangement of, not necessarily the arrangement, but it shows the size, the shape, the dimension, the length, and the total number of reinforcement needed for a job. That is what bar bending schedule means. When you hear bar bending schedule, probably you might be a layman that you don't know much about construction, and you are hearing bar bending schedule for the first time. So if you are hearing bar bending schedule for the first time, it's just a table that shows that, okay, on this part, on this section of the beam or of this section of the structural member, this is the number of reinforcement I'll be using. This is the one at the top. This is the one at the bottom. This is the size I'm going to use for this particular job. And that is what bar bending schedule tells you. It's going to tell you the bar mark, the length of the bar, the size of the bar you need. And one of the major uses is that it's going to eradicate waste in bar. Reinforcement is so expensive now. So if you have a bar bending schedule, it's going to tell you the quantity of reinforcement you need on site, so that you won't buy less or you won't buy more of what you don't need on site. So on this note, I have that bar bending schedule is a table which shows the size of bar mark on bar, the length, number, etc. It can be prepared with the use of AutoCAD, Microsoft Excel, and etc. So a bar bending schedule can be prepared using an AutoCAD and Microsoft Excel, which I'm going to use. I'm going to use AutoCAD in the second part of this video, just like I've said, and Microsoft Excel in the third part. So in the third part, I'm going to be comparing between two types of bar bending schedule that I always use. So that is what bar bending schedule entails. So whenever you hear about bar bending schedule in construction work, it just means a table that shows the number, the length, and everything concerning the enforcement. So the table that shows it is referred to as the bar bending schedule. Let's go to the next content, which is the uses of bar bending schedule. So from my explanation, you would have noticed some uses of bar bending schedule. So I have it here that a bar bending schedule is mostly used by the project engineer, the engineer, quantity surveyor, and IMR for work on site. So these people use this bar bending schedule. So project manager just uses it to monitor the job that have been done. The project manager, they have most of their function is to manage the project. So the work that have been done, project manager uses bar bending schedule to check if it aligns with the if the job executed align with the engineer use it to check work on site as well, just like the project manager. Engineer is involved in the day-to-day activities of construction on site. So you use it to check and make sure everything is done according to what is in the structural drawing. So a quantity surveyor might use it for quantification. So quantification in case a quantity surveyor want to know the number of enforcement needed for a job. So a bargaining schedule will help him or her to know, okay, this is the quantity I need for this job. And it's going to also help him in negotiating with the contractor. When you know the tonnage of enforcement you want to use, it is easier in negotiating with the contractor if you are going to buy or the person is going to buy. And the last person is the iron bender. I know the iron bender is involved in the reinforcement work, is a direct labor on the reinforcement work. So having a bargaining schedule, and if a iron bender is using a bargaining schedule and the structural drawing, it helps him a lot in doing his work, because there's no need to come to the drawing and begin to guess the length of rod, because the length and the dimension, the size are already in the bargaining schedule. So you just need to work with the bargaining schedule and the structural drawing in doing his work. So I have it there that it is used on site for number one, knowing the total number of bar required for the job, the total number of bar required for the job. And knowing the shape of the bar, now you're going to know the shape of the bar, where to have a bend, where to crank, where to deduct from, and where to add to. So a bar bending schedule will help you in knowing that, knowing the length and numbers of bar required. So it helps you to know the length and the numbers you need in a job. So just like the first one said total number, but this has to do with number. So when we start explaining the exam, when I start explaining the illustration, you are going to understand better on what I mean by this. So barberis could also help in knowing the size of the bar needed. It aid the engineer and project manager in supervision, just like what I've explained, and aiding the iron bender in doing his job and thereby making the job easy. So with barberis schedule, it's going to make the job easy. What most people do on site is they don't do barberis schedule, especially when it is a small job. Don't do a barberis schedule, just give the iron bender the structural drawing to go and work with it. So probably if you don't do a bargaining schedule, you might just take a rough schedule. Okay, probably in the drawing, editing you've done the bargaining schedule, what you might be needing might just be 10 tons. But because you don't have a bargaining schedule, you might say, okay, let's buy 7. And when you buy 7 and you find out that it is not enough, you need to buy more. Now you are spending more on the cost of transportation, and you are also delaying the project completion time. Because at the point you have a PowerPoint schedule that tells you that you need a total number of reinforcements for this job. You won't waste those time in waiting for additional reinforcement and spending additional cost on reinforcement. So I just tell you one of the advantage of bargaining schedule, and that is one of the uses, which is one of the advantage of the bargaining schedule. Let's go to the next slide, which is an example on bargaining schedule. So we're going to be doing an example, and let's say this is an illustration, right? It's an illustration in knowing the length of ring or stirrup to be used for a job. So I'm going to use this illustration to explain. So one thing you should know, one of the formula you should know in bar bending schedule are this formula, the bend deduction formula and the hook length formula. So we call it hook length. I'm going to explain everything with this diagram here. I hope you can see it. So I'm going to explain with this diagram. So let's say this is a concrete section. This is a concrete section here. We need a ring here. A ring here is going to be embedded in the concrete. So let me just talk about the formula first. A bend deduction. So whenever you are bending a reinforcement, a reinforcement is just a straight metallic object like this, right? So when you want to bend, let's say you want to bend this now, that part you are bending is going to shrink. That is why you are able to bend, because the reinforcement is ductile. You understand? So the reason why you are able to bend it is because that part you are bending is going to shrink. It's going to shrink together. So if you are bending at an angle of 45 degrees, now the formula you are going to know what to deduct from your reinforcement is 1D. That is it's 1D. So you want to bend at an angle of 45 degrees. So you just do 1 times the diameter of the reinforcement. D here represents the diameter of the reinforcement you are using. So let's assume you are working with a 10 mm reinforcement. I want to bend at 45 degrees. Now it's going to be 1 multiplied by 10, which is you are going to deduct 10 from the length of the reinforcement you need to cut. Now, you might not understand this right. When we start with the illustration, you are going to understand better. So when you are bending at an angle of 90 degrees, just like this is an angle of 90 degrees. Now, what you are going to deduct is 2 multiplied by D. Let's say this reinforcement is 10 mm, that 2 multiplied by 10, you are going to have 20. So you are going to deduct 20 here, 20 here, 20 here, 20 here. For 135 is 3D, for 180 is 4D. So now the hook length formula, the hook length, this is the hook. This is the hook, this is what we call the hook. This part is the stirrup, and the hook is part of the stirrup. Understand? The stirrup or the ring, depending on what I want to call it. So the formula is 10D. That is, if our reinforcement is 10 mm, then it's going to be 10 multiplied by 10, which is 100. So you are going to have 100 here and 100 here. That is how it is done. Meanwhile, people use other formula, like some people use 75, a nominal value of 75 for their hook length. Some people use a nominal value of 50 mm, depending on what you are using. But the appropriate formula to use is 10 multiplied by D. Although, just like I said, you can use some nominal value of 75 or 50, just like people use. Now let's go to the illustration. You might not understand this formula, but let me incorporate it here now, and you are going to understand what I meant. Now, illustration. Now let's assume a cover of 25 mm and a bar of 10 mm. By now you should know the meaning of cover. Cover is just the part of the concrete that makes sure that the reinforcement is embedded in the concrete. No, reinforcement is not supposed to be exposed to the atmosphere, because in the presence of water it's going to rust. You understand? So it needs to be embedded in the concrete. So the part where the concrete allows the reinforcement to be embedded in the concrete is called cover. So this area is regarded as the cover. This area of the concrete. It's cover. So let's assume a cover of 25 mm and a bar diameter of 10 mm. A bar of, let's say we want to use a bar of 10 mm as usual, because we usually use a bar of 10 mm and 8 mm for stirrup or ring on side. That is the usual reinforcement that is mostly used, especially 10 mm. So therefore, now we want to get the length of this total bar. We want to know the length we need to cut for the job. And I said, let's assume a cover of 25 mm and a bar of 10 mm. So therefore, the length of reinforcement will be 200 plus 200 plus 250 and all these values. So how do I come about all these values? Now, let's start from the top. The concrete section is 250 mm. The area of this is 250. Now we need to have a cover here. We need to have a cover here. So this is 25 and this is another 25 here. So we are going to subtract this 25 from this 250. That is 25 plus 25. We are going to have 50. Now 250 minus 50, we are going to have 200. So what you need here is 200, which is what you are going to cut. But you are not going to cut it now. You want to know the total number of length right now. That is how I come about the 200 here. You have 200 here, so you are still going to have another 200 here. Then at the side, the concrete section is 300, 300 from this part to this part is 300, and you have a cover of 25 mm also. So that is 50. 300 minus 50, you have what? 250. So it will appear here and here. So that is why you have 250 here and 250 plus this value plus the hook length. These are the hook length. From the reinforcement, you need to have an hook length here. So I said the hook length formula from this is 10 multiplied by D. So 10 multiplied by the diameter of the reinforcement plus 10, it is two numbers. 10 multiplied by the diameter of the reinforcement, then minus the bar deductions, the bend deduction rather. So now we know the length we need to cut, but we need to remove the bend deduction. And I said it earlier that the reason why we are removing the bend deduction is because we are going to bend, and when you are bending, it's going to shrink. So that shrinkage value of the reinforcement, we are going to remove it. So how do we remove that? I said for 90 degree it is 2D. We don't have 45 degree here. Now this 90 degree is 2D, which is 2 times the diameter of reinforcement, that is 20. But it appears 4 times at this bend here, at this bend, and at this bend here. It appears 4 times. So that is going to be multiplied by 4, which will give us 80. Then this hook length also appears at an angle of 135 degrees. So when we are bending an hook length, meanwhile, people do bend 90, but the appropriate value is 135. You bend at 135 degrees. So if you are bending the hook length, we have two lengths here. So this is going to be 3D. That's 3 multiplied by 10, the diameter of reinforcement, multiplied by 2. So this will be this is 30, this is 60, and this is 80, making 140. So the value you have from here, you are going to subtract 140 from it. That is 200 plus 200, making 400, plus this 2, making 900, plus this, making 11. So 11 minus 140, you are going to have this value. So that is how to know the length of bar you are going to cut. So from a 12 reinforcement, what we just need to cut for this ring is 960 mm. Just mark out 960 mm for the reinforcement and cut it. Then we can then bend it to form our ring. So that is an example of bar bending schedule. That is how to know the size of hook length, the size of ring you need to cut for a job. I hope that is very simple to understand. It is very simple to understand. I said I have an example also on a bar bending schedule I did. So I did this calculation. This is how a bar bending schedule looks like. This is how it looks like. Then I got all this from this beam. This is the beam and this is the section. This is a beam and this is the section. So I brought out all this from this. So assuming we want to do a job and the job is for only this beam, So just for example, you understand, just as an instance now, we want to do only this beam. Now what we need to do is to create a table like this. You have the bar mark, you have the beam, you have the diameter of the bar, you have the length of the bar, the quantity, the total, and the shape. So let me zoom this a little bit so it can be bold enough to be seen. Now let me go about how I come about this value. So the way I do my own, the bar mark, although from this drawing, when I molded the drawing, and before doing the detail, there is always a bar mark attached to all this reinforcement. But for easiness, for people to understand the drawing with ease, and that is why we do detailing, so that anybody that is reading the drawing will find it very easy to understand and use. So I decided to remove the bar mark, but this one you are having here is for beam 1. So I'm just taking it as beam 1. So from the list or the way I arrange my own beam section and column section, you are going to see it from beam 1. So the section of the beam is one, grid line 1, then G to A. The beam section is 230 by 900. 230 by 900. So I have it here. This beam 230 by 900. And diameter of the first bar I want to do the bar bending schedule for. The first bar here, which is the main bar here, is one of the main bar here, is this, which is 16 mm reinforcement at the top. That's what this is telling us. 16 mm reinforcement at the top. So that's why I have 16 mm here. That's the 16 mm reinforcement, and the quantity I need at that top is 3. So how do I know the length? I know the length from getting the length from here to where it stops, which is somewhere here if you are following my cursor. So the span here, the center to center dimension is 3210. But if I add this plus this crank value that is going to be, which is always 300, which is 300 there now, I'm going to have that shape. Now, okay, this is not clear enough. I thought it was clear enough. So you have the shape here. So in this a second part of the video, you are going to see all this. I don't know, this will not be clear on this video. I don't know, the shape will not be clear. But in the next video, you are going to see everything, because I'm going to, how I come about this value, I'm going to do it. So this is, I have a total length of 4540 from here. 4540, this is 4540 multiplied by 3. this 3 there, which is will give me this total number. Then I draw out the shape. Then the next reinforcement is this two number of 16 at the top here. So I have 16 I have it to be 2 and after measuring it, then it appears 2 times, then 2 multiplied by this, I have 4 2. Then I draw the shape. Then I will do the same for this, so which is what you have here. Then I will do the same thing for the bottom bar, this bottom bar here, this bottom bar here, and you have this for the bottom bar. Then I do for the runner, which is this runner here. The runner, we have a total of 6 number from the section so a total of 6, this is it here. Then for the ring, just like I just taught you now from the illustration I did, so the length of the ring is 200 and 2120. So how do I get 2120 as the length of the ring? So it just, this is 900 by 230. So this is 230. The cover is 25 mm. So this is 230 minus 50, which will give me 180. 900 minus 50, which will give me 850. So just 850 plus 850 plus 180 plus 180 plus 100, which is the hook length, then minus 140. So the 140 is just like a constant in my head now. Understand? Since it is having four, let me zoom it. Since it is having four bend here, then the 135 degree is here for the hook length. So I have a total of 2120. So and with this, I'm going to have my bar bending schedule. So at been I'm doing this job, this is the only job I'm doing. When I present this to my iron bender and I give my iron bender this drawing, with that, he's going to know what to cut and everything to do, and it's going to help me to know the reinforcement I need for the job as well. That is all for this video, for this part 1 of the bar bending schedule. So in the next video, I'm going to be doing this example from AutoCAD, how I come about the actual length, because looking at it from the structural drawing, you might just be specifying some length, although in the when you model, this part of the remaining reinforcement is always coming out from the, it will be shown to you. So most of the time I decide to remove it. So my drawing will be very easy to understand. It will not be too cumbersome. Just like this section, I'm supposed to have 2 sections if you are looking at it for me, but I just decided to have only one to make it very easy for anybody that is looking at it. So you will have more and more things on it. So in the next video, just like I've said, I'm going to be doing exactly this. I'm going to be doing it in AutoCAD, and you are going to, for you to understand better. So thank you for watching.